Okay, so 1.7 is about inequalities, and we are going to solve a nonlinear inequality. So that's going to be quadratic, cubic, quartic. We're mainly going to work with quadratics and cubic functions here, and also rational functions. So that's what we were doing in 1.4. So when you're solving nonlinear inequalities, they're going to have squares or other powers of the variable. We are going to use factoring together with this principle. Okay, so the book you have is a college textbook, and you have these little important blue boxes that explain concepts, but I think it's helpful for us to talk to that text so we understand what they're trying to say here. So the sign of a product or quotient, it says if it's a product or a quotient, if it has an even number of negative factors, then the value is positive. Okay, because if you're multiplying an even number of negatives, that's going to equal a positive. Okay, so that's all this is saying. If you have an even number of negative values that make the product or the quotient, it's going to equal a positive value. And then if you have an odd number of negative factors, then the value becomes negative. Okay, so we're going to be dealing with the product when we factor, and we're going to be dealing with the quotient when we have a rational function. Okay, so one thing I do really like about this book is they will give you some guidelines, which are really just steps to solving. So the first thing we're going to do is move all the terms to one side. Okay, and it's saying that if you do have an inequality that involves a quotient, which is just a rational function, you do have to make sure you have a common denominator. So we're going to practice that. And then you are going to factor the non-zero side of the inequality. Okay, then we are going to find the intervals. And we're going to determine the values for which each factor is 0. I'm going to do this part with you here. Okay, so we're moving all the terms to one side. Okay, if we need to get a common denominator, we will, if there's a quotient. Okay, and then we have to determine the values for which each factor is 0. Those are often referred to as key values. A lot of times there will be 2 of them if it's a quadratic. So it's similar to what we were doing with the domain. Remember, we'd have 2 values. For this, we'll call them A and B. And then we're going to write the intervals. Now, this time, the intervals could be brackets. It could include an A value. Could include the B value. But infinity is not a number, so that's always going to be a parenthesis. So we'll talk about the different cases about when you have a hard bracket versus a soft bracket. And then we're going to make a table or a diagram. So we're going to use what we call test values. In our table or diagram, and we're going to use the signs. Okay, so we're going to use these test values to make a table or diagram of the signs of each factor. And then in the last row, we're going to determine the sign of the product or quotient. Okay, in the last row of the table is where we're going to put the sign of the product or the quotient. Okay, and then we're going to solve. So we're going to determine the solution of our inequality from that last row of the signs. Okay, so we determine that from the last row of the sign. Okay, so we're going to walk through this with our first example. We are going to solve our nonlinear inequality and we're going to express our solution using interval notation, and we're also going to graph the solution set. We're just going to do that on a number line. Okay, so we're going to be graphing on a number line here. All right, for part A, we have x squared minus x minus 2 is less than 0. So it is nonlinear, it's quadratic. We're going to follow the guidelines from above. So step 1 says move all terms to one side. Lucky for us, that is done. So we don't have to worry about it here. We can go to step 2, which is where we factor. So when you're factoring, remember, you want to multiply to x squared. So we're going to start with x and x. Go ahead and finish that part. You're looking for two numbers that multiply to -2, and then they have to add to -1. Okay? Anytime this ends in a negative, you know that your factors are going to be opposites, right? A plus and a minus. So to get -1, you need a -2, a +1. Okay, and then for step 3, it says find the intervals, determine the values for which each factor is 0. So the factors are these two, okay? So what could I plug in for x here that would make this first factor 0? Yep, -1. So mine would be -1. So -1 is one of our values. Okay, and then for this one, what could I plug in? 2. Make sure that when you line them up here that they are in numerical order, or else your intervals are not going to be correct. So -1 goes first. You don't necessarily have to make your number line here, but this shows you how many intervals you have. Okay, so you have -1 and negative infinity. So this first interval here is -infinity to -1. And it is going to be a parenthesis. Can anybody tell me why you think that is? Yeah, so it's based on this sign. Okay, so if there's no equal to, it's going to be a soft bracket. So that's what tells you what it is. Okay, and then this interval would be -1 to 2. Again, those are going to be soft brackets. And then 2 to infinity. When you're doing this on your assignment, you don't have to make this twice. In fact, I'm going to show you how you can change that into a table. Okay, and now, when we make the table or diagram, we want to pick test points that fall in the intervals. You cannot pick these key values, though. So you can't pick -1 or 2, and that's because these lie in both of them. So that would be an indeterminate value. Okay, so a number between -1 and -infinity, most of us are going to choose -2, but anything less than -1 is fine. Okay, a number between -1 and 2, 0. You could also choose 1 if you wanted, and then a number above 2, 3 is going to be the most common. Okay, so it said to choose a test point. That's what we're doing. Okay, these are our test points. They have to be in each of those intervals. Now what you do is you plug those test points into each factor. So the factors here are x plus 1 and x minus 2. Okay, that's what we call the factors. That's what we're going to put here. Okay, now the first time you do this, I'm going to plug it in to show you, but really you're going to be doing this in your head. If you plug in -2, -2 plus 1 is -1. All you have to record is the sign. So -1 is a negative. That's all you need to write in your table. Okay, what I have boxed in here, that's your mental math. So when you do -2 minus 2, you get -4. Okay, that means that it's negative. So that's all you have to put there. The last row is the sign of the product. When there's just two, you can just remember, hey, if you have a negative times a negative, it's going to be a positive. Okay, so let's do this one with mental math, where we're just plugging them in. So if you plug in 0, 0 plus 1 is a positive. 0 minus 2 is a negative. A positive times a negative is a negative. Okay, and then can you go ahead and do the last row for me? Left column. And once you've done that, I want you to think about what the solution is. Okay, so when we plug in 3, we get 4 and 1, which are both positives. Okay, what we talked about in that first box are if you have an odd number of negatives, it's going to be negative. If you have an even number of negatives, it's going to be positive, and that still holds true. Okay, so the sign of the product, your solution is going to depend on your equation here. So this equation is less than 0. So if it's less than 0, what intervals do we want? Do we want the positive or the negatives? We want the negatives. Okay, so if it's less than 0, the negative intervals are going to be our solution. Okay, so that means our solution is going to be this interval here because it resulted in a negative. Okay, so all you have to write for your solution is a negative 1, 2, and then we are going to graph that on our number line. And I'm fine if you just put your key values there. If you have the sock brackets, you're going to have an open circle at both of those. And what this represents is any number between negative 1 and 2 is going to make this true. Okay, so if you plug in any number in between those, this is going to be a true statement. Anything that's not in there would make it false, and so it would not be a solution. All right, questions for me on that part? All right, let's try the next one. So why don't you go ahead and try the first few steps here. So we're moving everything to one side, we're factoring, and then we're finding those key values. Okay, so once you're ready to factor, we know we have to start with 2x and x. If it multiplies to negative 1, you have to have opposite signs. The middle is 1, so I'm going to put a plus 1 here, negative 1 there, to get negative 1 plus 2, which would add to negative 1 there. Okay, so remember we're trying to find what makes each factor 0. So if you need to, you can always set it equal to 0 and solve. Add 1, divide by 2. X equals 1/2 would make that 0, and then this would be negative 1. Okay, when you are putting this on your number line, just make sure that you put them in the correct order so that your intervals are correct. Okay, now here you have the equal to. So if you have the equal to, you're going to have brackets. So the first interval is negative infinity to negative 1 with a bracket. Okay, then we're going to go from negative 1 to 1/2. and then 1/2 to infinity. Okay, now we're going to choose our test point. So I just need a value that is less than -1. I'm going to choose -2. 0 works for our next interval. 1 works for the last one. And here we are putting our factors. Okay, so this part should go pretty quick. When you're plugging it in, you can tell if it's negative or positive. An even number of negatives will make a positive. I plug in 0, I get a negative and a positive, which is negative. I plug in 1, 2 minus 1 is 1, 1 plus 1. Okay, now this time you have that it's greater than or equal to 0, which means you're going to have a positive interval as your solution. Okay, it's greater than or equal to 0. So when you have two intervals that are solutions, we're going to connect them with what? A union. Okay, so actually here, I think I actually have room to write here. Your solution is -infinity to -1 in union with 1/2 to infinity. Okay, and then again on your number line, I'll put that here, so it's going to be a closed circle going to the right. You can make yours over here if you didn't leave enough room for this. And this would be going to the left. Okay, so all of this is your solution. Yeah, so depending on what your situation is, if it's the equal to, we're going to have brackets. Here, this is greater than 0, so it's positive. Okay, so whether it's positive or negative, hard brackets or soft brackets, that is going to be changing from problem to problem. Okay, and then this one's going to be a little different if you guys want to try to start that. Okay, so this one's different because it's cubic, so we are still going to follow our same rules of factoring. So once we get everything to one side, when we factor, what's the first thing we should be looking for? Yeah, your GCF. What's our GCF here? X. So if I take out an x, I get x squared minus 8x plus 15. Okay, so go ahead and factor that, and yes, you will have 3 intervals. So we're gonna add columns into our table. Remember, if the last one is positive 15, that means the signs have to be the same. So if it's -8, those are both minus. So don't forget this guy is also a factor. X is a factor. So what will we plug in for x to get 0? 0. X minus 5, we would plug in 5 to get 0. X minus 3, we would plug in 3 to get 0. And then again, we just want to make sure we put these in numerical order. Okay, and then now we have 1, 2, 3, 4 intervals. So just gonna put line down here so we can list those all out. Okay, it's equal to, so that means we're going to have brackets. So the first one is negative infinity to 0. The second one is 0 to 3. Then we have 3 to 5 and 5 to infinity. Okay, again, remember the test point cannot be in the interval. So I can't choose 0 here. So I can choose -1 and 1. Between 3 and 5, I can choose 4. If you ever have like numbers that are right next to each other, you can choose the decimal. That's fine. Okay, we just try to pick the simplest numbers to plug in. Now we have 3 factors. So we are going to have 3 signs. We have x, we have x minus 5, and we have x minus 3. Okay, so if I plug in -1, it's negative, this would be negative, this would be negative. Whenever you have an odd number of negatives, it's going to stay negative. For 1, I have positive, negative, negative. I have an even number of negatives, so it's positive. I have positive, negative, positive. I have an odd number, so it's negative. I have positive, 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 so it's going to be positive. Okay, so I'm going to look at my equation. I have everything is greater than or equal to 0, which means my positive intervals are what I'm looking for this problem. Okay, so my solution intervals are going to be the 0, 3 and the 5 infinity, and I'm going to connect those with a union. Okay, so my solution is going to be from 0 to 3 in union with 5 to infinity. So anytime I have a bracket, it's going to be a closed circle. So I have a closed circle on 0, a closed circle on 3. I have a closed circle on 5, and that is going to go to the right. Okay, so that is going to be my solution. Any questions for me on those? All of those are products. So there's only one more type we have to seek, and that is the quotient. So a quotient is just a rational function. So for D, it's 6 plus x over 6 minus x. That is greater than or equal to 1. Okay, so our first step is to move everything over to one side. So we have to move that 1 over. Okay, and you might remember when we were going over our first steps, we talked about if you have a quotient, then you have to bring them to a common denominator. Okay, we want to make this one term on the top and one term on the bottom. So we are going to have to get a common denominator here. Okay, and then we're just going to write that work over here because there really just isn't enough room there. So to get a common denominator, we are going to multiply -1 by 6 minus x over 6 minus x. Okay, this is very similar to what you did in the 1.4 quiz. It's just you didn't have that inequality there. You can think of this over 1. Just remember you are going to have to distribute. Okay, so when you do that, I'm going to write it over here. You have 6 plus x. -1 times 6 is -6. -1 times -x is +x. That's all over 6 minus x. Okay, and then if we simplify that, 6 and negative 6 cancel. X plus x is going to be 2x. And so this is going to be our inequality for step 2. We have 2x over 6 minus x is greater than or equal to 0. Okay, so we're keeping that inequality there. Okay, so what we did here is we have to get the LCD, which we did. Okay, and then our factors are the numerator and denominator. Okay, so whatever you're dividing by, those are the factors. So for the sign of, it's going to be 2x, which is the numerator, 6 minus x, which is the denominator. Okay, and then this one is a little different as well. So if this is your factor, what could I plug in for x to make 0? 0. For the denominator, what would I plug in for x to make 0? 6. Now, because we have a fraction, we have to remember that fractions have special rules. You can't have the denominator of a fraction equal 0. So because the denominator can't equal 0, we have to make sure that this has a soft bracket. And it's only the 6. Okay, it doesn't matter if the numerator is 0. Okay, so because you have the equal to here, you're going to use a hard bracket for the term that's not in the denominator. Okay, so you're going to use a hard bracket except where the denominator equals 0. Okay, if it was just a greater than, you wouldn't have to worry about that. But because of this equal to here, we're going to be using a hard bracket and then a soft bracket. Okay, so I like to see these on my number line. So the first part is going to be negative infinity to 0. Remember, that's a hard bracket with 0. Okay, the next one would go from 0 to 6. Now, we talked about 6 is going to have a soft bracket, but 0 is still going to have that hard bracket. So you have 0 with the hard bracket, 6 with the soft bracket, and then the last one would be 6 to infinity, both with your soft brackets there. Okay, so now we can do our table. Again, we're picking a value that's less than 0. We don't want it to be 0, even though it says it includes it, because it includes it in both. That is one of your key values, so you're never going to use one of your key values there. Okay, and then we're going to plug them in and find the sign. So we have a negative. Remember, minus a negative is a plus here, so that's going to be a positive. You have an odd number of negatives, so it's a negative. When you plug in 1, you get 2 and 5, which are both positive. When you plug in 7, you get a positive and a negative, which will be a negative. And then we got to look to the sign to see if we're doing the positive or negative for this one. Okay, so if it's greater than or equal to 0, that means we're going to use the positive interval. Okay, that's going to be your solution. Okay, so your solution is 0 to 6. So you are going to put a closed circle at 0, an open circle at 6, and you're going to connect those together.